Problem of the day? Ready? Here we go. 2 minutes, go. Should take way less than 2 minutes. What do you guys think? Which one?
E.
Who thinks it's E? I think it's E. Why do they have this here? That's why I chose this problem, because they do this often. Why do they have that as a choice for that?
Yeah. But like, I mean,
Why would that be a common mistake? That's my question.
I don't know, I could see how someone's like train of thought because
It's the integral. Yeah, so that's a really common thing that they're going to do. They're going to try and confuse you because you're trying to rush through, and you have to be careful that you don't integrate when you're trying to differentiate, but differentiate when you're trying to integrate. Okay, so that's just the thing. Like, just be aware that that's how they're trying to fool you in this problem. Okay, if you're aware of how they're going to try and fool you, then you're less likely to be fooled. That's my opinion. Okay, all right. So today, well, first, before I start, there's going to be a test next Thursday and Friday, 28th and 29th. It's 2 days. One day, the first day is going to be no calculator, and the second day is going to be calculator. Okay? The 2-day test next Thursday and Friday is just on unit 6, the test of the unit we're doing now. Okay? So we have a couple more days of notes, and then we'll review for a couple days, and then the test will be Thursday and Friday. Any questions on that? So the personal progress checks for Unit 6 are already posted. They're not due until the day of the test, though, the 28th. There's also a practice test for Unit 6 that's posted. You can do that. It's optional. You don't have to do that, but you can do it if you want, just for some extra little problems if you need them.
But we still have notes to do, so we don't have to do all of the.
Right. Yeah. Is it possible? Must be like to like start a personal progress check and then skip questions and then come back to them.
Yeah.
Oh, it is possible. Okay. Yeah, so you can do that if you want. I don't want people to have to rush through it and then not like think about it and do a good job. All right. Any questions on that then? And I've actually like planned out like. But we're almost done. We're literally almost done. The next unit is going to be like 6 days, and that's it. It's just about differential equations, like more differential equations. And then there's a short unit after that, Unit 8, and we're done. We'll be done by March 4th, and the AP exam isn't until May 4th. So we'll have 2 full months. Yeah.
Will we keep having tests during this month? Or will it just
It'll be like practice questions. In terms of grading, I'm not quite sure how that's going to work yet. I mean, I'll probably count some of them as grades, but after the AP exam, we'll be completely done. There'll be no more grades after that. So the fourth quarter grading is going to be a little bit different. I'll explain how that works later. No, I'll explain how that grading is going to work, but you'll all be satisfied, I'm sure. Okay? Any questions about that? Okay, today I just wanted to review something and then talk about how it relates to this unit. So this is a topic that you should have learned in algebra, but I'm not quite sure if it's taught or not. It's long division of polynomials. So is this something that you guys know how to do?
We learned it, but I don't remember.
All right, so let's just review. So if you have, well, first, let's just review like numbers. Like if I have two numbers and I want to do long division of these numbers, like say I wanted to do like 57,396 divided by 3. I know it goes evenly. How do I know this goes evenly and I just made this number up? What's the test for divisibility by 3? Yeah, if you add up the digits, that sum is divisible by 3. These add up to 12 plus 3 plus 9 plus 6. I don't know what that sum is, but I know it's divisible by 3 because all the little pieces are divisible by 3. Okay, so I know this goes evenly. There's not going to be a remainder. But then remember how this works. So I want to first decide, like, how many times does 3 go into 5, right? So it goes in once, that goes there, and then you multiply these two together, and that product goes here, right? What do you do next? Subtract. Yeah, you subtract this from the number above it, and then you bring down the next thing unchanged. And then you just repeat the process, right? So 3 goes into 27 9 times. 9 times 3 is 27. You subtract, you get 0, and then you bring down the next thing. 3 goes into 3 once. Product is 3. You subtract, and you bring down the next thing. It's 3, 9, 0. Bring down the last thing. So 2, 6, and then you subtract, and you get 0. And whatever ends up being here is the remainder. Right? This is all familiar to you. Okay. So if you have polynomials that you want to divide, it's the exact same process. So suppose I have, I got one that I rigged, so it works nice and evenly. So suppose I have something like 3x squared minus x minus 14 divided by x plus 2. Okay, the first thing I'm going to do is I'm going to decide what needs to be multiplied by x to give me 3x squared. So it would be 2x, right? Or 3x, 3x. So this goes 3x. This is what needs to be multiplied by x to get this leading term. And then you multiply them, just like you would before, but you have to distribute in this case. So it's going to be 3x squared plus 6x. And then you subtract. But you're subtracting a polynomial, so parentheses are necessary. The first term is always going to cancel, because that's the way you got this, is what's going to make this exactly 3x squared. So that's always going to happen, like those will always cancel. These two won't always cancel. So if I take negative x minus 6x, I get negative 7x, and then bring down the next term. Then you repeat the process. So the next term of the quotient here would be minus 7, right? Because that's what needs to be multiplied by x to give me negative 7x. And then you multiply, so you get negative 7x minus 14. You subtract these, you get 0. And then that's the remainder. So this goes evenly. You take 3x squared minus x minus 14, and you divide it by x plus 2, the exact answer is 3x minus 17. Now, if you get something that's not exact, like suppose I have a polynomial that doesn't divide evenly, suppose I have something like 5x squared plus 2x plus 1 divided by x minus 2. I'm assuming this doesn't divide evenly because I just made this one up. So this is going to be 5x. If I multiply it out, I get 5x squared minus 10x. Then subtract 2x plus 10x would be 12x. Bring down the next term. So this would be plus 12. And then I have 12x. Minus 24. So when I subtract these, I get 25. the remainder is 25, right? So the way you could write this is the original division problem, like if I take 5x squared plus 2x plus 1 divided by x minus 2, this is really equal to 5x plus 12 with a remainder of 25, which means it's really like plus 25 over x minus 2, right? When there's a remainder, this is the way you can write it. Like, for example, if I were to take something like 516 and divide that by 3, well, that goes in. Divide it by 5, right? Well, what would this be? This would be 1, and then 5, and then subtract, and then 0, 0, and then subtract, bring it down, and you get 3, and you get a remainder of 1, right? Well, that's like saying that this original division, 516 divided by 5, is really 103 and 1/5, right? It's whatever this remainder is divided by the divisor, dividend divisor, right? So that's just what I did here. I took the remainder and put it over the divisor as the kind of like the remainder over here. It's 25 over x minus 2. That makes sense that this is really equivalent to this. The same situation as this is equivalent to that, okay? Everybody okay with that? Now, a couple little things, like sometimes you might have polynomials that are missing terms. Like suppose I had something like, if they wanted us to take x cubed plus 2x minus 1 divided by 3x plus 2. Okay? So this would be, in order to do long division here, you have to have a place for each thing, because otherwise the terms don't line up correctly and you can't subtract them because they end up not being like terms. So in order to do this long division, you have to take x cubed plus 0x squared plus 2x minus 1. Like you have to have every possible exponent going down to nothing, okay? Now this one would be kind of a pain in the neck because I'd have to have fractions. Like this would be like 1/3 x squared, and it just turns into a mess. But you get the idea. Like my point was, you have to have a placeholder. Same thing goes for if this happened to be like a quadratic that didn't have an x term, you'd have to have a placeholder over here as well, because otherwise, when you multiply it out, the terms are not under the correct terms to subtract. Okay. Now there's a shortcut way to do this, but I don't think I'm going to show you how to do that because it might get a little confusing. So I'm going to forget that. All right, so any questions on this so far? Okay, so that's the first thing I wanted to remind you of. The second thing I want to remind you of is completing the square. So we've done this lots of times. You've done this lots of times. And most of the time, the context is like to solve a quadratic equation, or possibly to like find the center of a circle that's not in standard form, or something like that. Okay. So here's just a reminder of how that works. So if I'm trying to solve a quadratic equation, okay, so something like x squared minus 6x plus 13 equals 0, or something like that. Okay, if I wanted to solve this by completing the square, remember the way that works is I move the 13 over so that I just have the x squared and the x terms on the left, but I'm going to leave a little bit of space, right? Then you take half the coefficient of x and you square it and you add it to both sides, right? So you're going to take half of -6, which is -3, and I'm going to add -3 squared to this side. But whatever I do to one side, I have to do the same thing to the other side. I'm going to add -3 squared to this side. And the benefit of doing that, the benefit of choosing this number in the way that we did, is that this now becomes a perfect square. That's why it's called completing the square. This now becomes x minus 3 squared, right? Whatever this term is, plus whatever this term is, which is why I didn't write this as plus 9, because then I would maybe forget that it's negative 3 and not positive 3. Okay? And then on the right, I have negative 13 plus 9, which is negative 4. And then you just square root and all that stuff. So this is going to be x minus 3 equals plus or minus 2i, x equals 3 plus or minus 2i, and that's the answer. Everybody remember that? Completing the square. Okay, so what we're going to talk about today is integration problems that require you to either do long division or complete the square. Okay? And how you can recognize those problems, and then what to do and how to do it. Okay? It's not as difficult as it sounds. Okay? So let's just look at some examples from the homework for tonight. So these are actual problems from tonight's homework. Okay? So tonight's homework is an AP Classroom because I couldn't find any other source of questions that look like this. So tonight's homework is just called Homework 120. Okay? So let's just look at some of these problems. All right, so here's the first one. So we have the integral of 4 over x squared plus 4x plus 8. Now this isn't going to work. Forget about the choices that are here, okay? If I just had this as a free response question or something like that, I wouldn't know how to do this because I can't do u substitution because the only u that I would probably think to pick is the whole bottom. But then its derivative has an x in it. There's no x there. That's a factor that it's going to cancel with that. So it's just not going to work. I would not be able to figure out how to do this problem if it wasn't multiple choice. Now, if I look at the choices, I can see that the choices are an ln, which this is probably a common mistake because people are like, oh, 1 over u. Its derivative or its integral is ln u. But that doesn't work, right? Unless it's just a u, right? Or unless it's a u whose derivative happens to be just a constant, then I can just divide by that constant and do my little shortcut u substitution. This isn't that, right? So it's definitely not A, which leads me to believe it must be something that involves inverse tangent. Well, if you think about the formula for inverse tangent derivatives, or integrals rather, what's the formula for it? Like, what integral yields inverse tangent as an answer? 1 plus u squared or x squared dx, right? This is inverse tangent of x plus c. So my goal is actually to make this look like that, okay? So this is a completing the square problem, okay? Because that's the way that you can take multiple terms like this that contain x and turn it into just a single thing that's squared. Follow me so far? So here's the process. I'm just going to complete the square on the denominator here. So this is going to be 4 over, I'm going to write this as x squared plus 4x, leave a little bit of space, plus 8. And then I'm going to complete the square on this denominator. So if I complete the square on this denominator, I take, I forgot my x. If I complete the square on this denominator, I'm going to take half the coefficient of x, square it, and add it on. So I'm going to add 2 squared here. But here, I have to subtract 2 squared. Okay, this is kind of like the problem where we just solved the quadratic equation, except now, instead of adding the same thing to both sides of the equation, I just have to do the inverse operation in the same bottom, because now I've really done nothing, right? If I'm adding 4 and subtracting 4, net result is we're all good, right? So now this becomes the integral of 4 over, if I look at these first 3 terms, that's a perfect square. Just by the way we selected this 2 squared, right? So that is just going to become x plus 2 squared. And if I take negative or plus 8 minus 4, I get plus 4. We're getting closer, right? Now it's more like one of those hard ones that I always have trouble with, the integrals that end up giving you inverse trig answers. It's one of those now, in a much more obvious way, right? So what's kind of wrong with this? Like how is this different than that? The 4, right? So remember the process is now you just multiply the top by 1/4 and you multiply the bottom by 1/4. So now I can write this as the integral of 1 over, now if I distribute this 1/4 into that term, it's really going to be x plus 2 over 2 squared. Okay, so far? Now, finally, I could just do my shortcut u substitution thing, because the u that I'm going to pick is x plus 2 over 2. And what's its derivative? 1/2. So all I need to do is just take inverse tangent of x plus 2 over 2 divided by 1/2, which is times 2, plus c. There's the answer. So the answer has to be B. So my initial thought was, I can't do this problem because it's not u substitution, right? But then I looked at the choices, ruled the one that has ln out, because I know that that's not right. That's a common thing that they're going to try and fool you with, right? So now I know it has to be inverse tangent. So then my focus was just trying to make it look like this. Are we okay with that? All right, let's do another one. I'm going to erase this and then go to problem number 2. Right? 2. So, kind of the same issue. I think common mistakes would be, one common mistake people would do is they would try and split this up into 2 fractions. That does not work, right? It only works, you can only split up into 2 fractions if the denominator is a single term, right? Like, if I have something like a plus b over c, that's definitely equal to a over c plus b over c. But if I have a over b plus c, that is certainly not equal to a over b plus a over c, or a over c. Okay, so this doesn't work. This does. So this is not one of those, right? Don't do that. That would be my first mistake that I think people would make. And I'm surprised they don't have a choice for that, but they don't. Okay, so then the next thing that I would try and think of is u substitution. But remember, whatever you pick, there has to be a constant multiple of its derivative as a factor of the integrand, and that's not here, right? Like, if I pick this denominator to be u, there's an x there that's never going to cancel with anything, right? If I pick the top to be u, maybe I can work it out because this is a linear term. I might try that, but I don't know if it'll work or not. But the key thing I'm thinking is all the choices have ln's in them. Okay, so this is actually a long division problem. I can actually just divide 12x squared by 2x plus 1 and turn it into a polynomial plus 1 over, or plus not 1 over, but something, a constant over 2x plus 1. That constant would be the remainder when I do long division. And that's going to give me this ln of 2x plus 1 that appears in every single problem. Okay? Everybody understand my thought process? So I'm going to do the long division. I'm going to take 12x squared plus 0x plus 0, and I'm going to divide that by 2x plus 1. So this is going to be 6x. I multiply it as 12x plus 6x. 12x squared plus 6x. Subtract, those cancel, I get negative 6x. Next term would be minus 3. Now, maybe I could stop here, because if I look at the choices, if this is going to be plus some remainder, whatever that happens to be, I mean, maybe I can't stop, but I can definitely rule out these two. Those are definitely not right, because the derivative, or the integral, is 6x squared over 2 minus 3x, which is these two terms. So it's one of these. Does that make sense? Multiply them out, I get negative 6x minus 3. Subtract. What am I doing? I forgot to bring it down to 0, sorry. And then subtract, so I get 3. The remainder is 3. So this is plus 3 over 2x plus 1. So now I can do it easily. If this is the integral that I'm taking, if I'm taking the integral of that stuff, it's just 6x squared over 2 minus 3x plus 3 ln of 2x plus 1 divided by 2. That's the shortcut u substitution right there, plus c. So it has to be just c. Does everybody understand? Again, these are types of problems that maybe you'll see one multiple choice question on one of these two things, either completing the square or long division of polynomials. And if you have that tool in your box, then maybe that's one you'll get right. You know, it's not the end of the world if you don't know how to do it, but, you know, helpful if you do. All right, let's look at number 3. So right off the bat, do you think this is a long division problem, or do you think this is a completing the square problem? Yeah, you can't. We can only do long division of polynomials, and that's definitely not a polynomial. Plus, you can't do long division if the numerator has a lower order than the denominator. That doesn't work. Okay, so this has to be a completing the square. So I'm looking at all the choices that involve inverse trig, and there's all inverse sine. So what's the rule for inverse sine? 1 over square root of 1 minus, I'm just going to write 1 minus u squared du is inverse sine. So that's my goal. Make it look like that. Okay, so they kind of arrange things in the correct order here. I have 8 over the square root of 12 minus, now, actually leave a little bit of space. It's going to be 12 minus parentheses x squared plus 4x. Right, so far I've changed nothing. I just grouped things together. Then I'm going to complete the square. So in here I'm going to add 2 squared. What do I have to do over here? What's that?
No, you added
I have to add 2 squared, because the net result is there's this negative sign out here, and I really subtracted 2 squared. So here I have to add 2 squared again. Is this making logical sense? I don't want you to look at me just doing something and be like, I would never be able to do that on my own. I want you to like make sure that this makes sense. Okay, so this is going to be 8 over the square root of 12 plus 4, 16, minus x plus 2 squared. We're not quite ready to integrate yet. What else do we need to do? The 8's not such a problem. We really need to fix that 16, right? It's okay if there's a constant multiple, like if this was just an 8, but that was a 1, we'd be good to go. It's just going to be 8 inverse sine, blah, 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 right? But it's the 16 that's messing us up. So I got to multiply the top and bottom by 1/4, right? Or 1 over the square root of 16. So 1/4 up here, and 1 over the square root of 16 here. So this is now 2 over the square root. Now I can distribute that radical 16. I get 1 minus, it's going to make 16 under here. So this is going to be x plus 2 over 4 squared. Now I can go. This is just going to be 2 inverse sine of x plus 2 over 4 divided by the derivative of x plus 2 over 4, which is divided by 1/4, which is times 8. Let's see. So this is just going to, this just is a net result of 8 on top. So it's D, right? Yeah, it's D. Want to do one more, or do you want to try the other 3 on your own? I'm going to find another one that does long division.
We try it on our own right now, and then do it.
Yeah, sure. Let's look at 4 and see. Just first glance, is number 4 going to be a long division or a completing the square? Long division. So you want to do that one, or do you want me to find the completing the square one? All right. I'll do it while you're doing it, and we can go. Hello? Sure, no problem. Yep, bye. Oh, I just couldn't watch it the other period.
Okay.
All right, who has a guess? This one has a 4 there, this one has a 2 right there.
I got C.
Did anybody else get C? I got C. Let's go through it. 4x cubed plus 0x squared plus 0x plus 0 divided by 2x plus 3. So this is 2x squared, 4x cubed plus 6x squared, subtract negative 6x squared plus 0x minus 3x negative 6x squared minus 9x, subtract 9x plus 0. Now this gets a little weird. To get 9x, you have to multiply 2x times 9 halves, or plus times positive 9 halves. All right, so it's going to be 9 halves. Then when you multiply it out, you get 9x plus 27 halves. So the remainder is negative 27 halves. So this is going to be plus, or minus rather, minus 27 halves times 1 over 2x plus 3. That's the long division, right? So when I do the integration, it's going to be 2x cubed over 3 minus 3x squared over 2 plus 9 halves x minus 27 halves, that's just a constant multiple, times ln of 2x plus 3 divided by 2. So the 2 and the 2 multiplied before, the answer is C. Did everybody see where you went wrong if you got the wrong answer? Now this is one that it would probably take me longer than 2 minutes, right? So if I'm going through multiple choice and this comes up in the non-calculator question, and I know that I should have about 2 minutes to do it, this is probably going to take me a little longer. Write a note next to it, say this is going to be long division, and then move on to the next problem. And when you get done with all your multiple choices, go back to the ones you skipped, and now you have a note reminding you to do. So if you have an extra few minutes at the end, you can get the right answer. Or maybe you don't have time to do it, but you know it can't be this or this. You know it's one of these. Then you can pick one. At least you're giving yourself a 50% chance instead of a 25% chance. You see this test-taking strategy? Don't ever leave a multiple choice question blank. You don't get like minus points for getting them wrong. You just don't earn those points. But so don't ever leave a multiple choice question blank. But it's okay to leave them blank and then go back to it at the end. Okay. All right. So like I said, the homework is on AP Classroom. There's 2 more questions, number 5 and 6. You can just do those 2 questions. That's fine.